So, projectiles. There's about a million different ways that they can be handled, and there isn't really a standard practice, but it kind of depends on how you want them to work. So for my game in particular, they're super important. They're the main source of damage, there's going to be a lot of them on the screen at the same time. There's a lot of weapons, so there'll be a lot of variety in what projectiles there are, and there's also going to be multiplayer, which means they have to function well enough to exist within a laggy environment. Which means for me, projectiles need to be flexible and performance friendly, and there can be a lot of them. Which, given Unreal Engine 5 has a particular reputation it wants to maintain, it certainly took me a while. That's why this video was as delayed as it is. Not only that, but because I want to make a lot of these, if I can somehow minimize the actual amount of coding I need to do for any part of it, I'm going to try doing it. I'm going to split this video into a few parts, talk about how each section of the projectile system works, and for ease of viewing it's going to be in the order that the code happens. Step 1. Spawning everything. Yes, everything. And at the beginning of the level, no less. It needs to start that early. Something that needs to be explained before anything else is something called memory fragmenting. Think of it like this. Every single object in Unreal that exists at any given time is on a single giant memory list. That memory list can be infinitely long, but it never is. It's only as long as however many objects are in the game at any given moment, until something's removed. When that something's removed, that piece of list stays there, but it's just empty. And when something new is spawned, that empty piece isn't filled up, instead a new piece of list is added at the bottom. And while it's true the longer this list gets, the worse the game performs, this list can be a few million things long before the game actually starts taking a performance hit from the list's length. But actively modifying this list causes a far more noticeable hit to performance every time it happens. In other words, spawning and despawning one projectile causes more lag than having 50 already spawned projectiles flying around at the same time. And this is where memory fragmenting comes into play. Those empty spaces on the list are still being referenced even though it really shouldn't be, and because Unreal essentially needs to search the entire game to try and find what it's referencing now that it's missing, it's slowing the game down. You're essentially confusing the game with empty junk. These fragments of memory only really exist to cause problems. The way around this? You make the list super long right at the start of a map being loaded, and then instead of an actor spawning and despawning, you create one that can be set to active and inactive. And while this does cause a massive performance hit for the first few seconds of the map loading, it's still a much better alternative to causing frame drops every time something's spawned and despawned. The way to do this is to create a component, which if you've never used Unreal before is like a section of code you can carry from one actor to another. This component will spawn however many projectiles you want, and have a function that mimics the spawning of an actor. But instead of actually spawning that new actor, it just moves an inactive actor to where you want and sets it to active, which is functionally the same thing. This method of lag avoiding is called actor pooling, and it's going to show up every now and then as I talk about this. If that explanation didn't make much sense, then think of it like this. Spawning and despawning causes memory fragmenting, memory fragmenting slows down the game, and actor pooling is the method that's used to avert memory fragmenting from happening. So here's how this looks when you actually try putting it into the actual game. Or at least this is what the end result looks like. You'll notice just there, when I pressed play, the game said spawning 50 actors at an arbitrary location. Those 50 actors, or projectile actors, belong to this character here. He can't actually shoot them, but those 50 have been spawned. And as you can see here in the little outliner, all of those projectiles have been spawned. So he can't actually use them, that's not important. So when I click testing here and load the other level, you can see 300 were spawned. 300 actors were just spawned right now, and you'll notice the game is running pretty much fine. And this game is actually really unoptimized at the moment. I still haven't really figured that out yet, but 300 actors were spawned, and as proof, if I just scroll down here, look at all that. That many have been spawned. but because they're not doing anything, it barely actually impacts the game itself. Performance realistically hasn't done anything bad because, well, they don't have to render the projectiles aren't doing anything, they just exist in God knows where right at the bottom of the map doing nothing, and that means inactive projectiles, completely negligible to performance. So now that the method of spawning has been figured out, there's another issue that needs to be dealt with pretty much immediately. This game has a lot of projectiles. Those projectiles will act different, they'll look different, they'll be fired in different ways, some of them may not even be actual projectiles, they may just be like little stand-in placeholder explosion thingies. But the point is, there's a lot of different kinds of projectile in this game, and this spawning method has a bit of an issue, because at the start of the map, they've already all been spawned, so it's kind of predetermined what will be fired. So that means there has to be a way around this in order to have that projectile variety without pretty much splitting the game in half. I've found 3 ways around this that I think are the most feasible. You can either A, have a different actor for each projectile, and have a different spawn pool for each actor. That would mean that you'd probably end up having to make a ton of different components. Immediately bad idea. B, have a different actor for each projectile, but have only one pool that shares them all. This causes the same sort of problem, but now there's also the chance of spawning the wrong actor every time you shoot your gun. Also a bad idea. Or C, having one single projectile actor for every projectile, and having one pool for that one actor. That's stupid enough to work, but with a lot of different projectiles, that means that they all have to act different, even though it's a single actor. So, how would you make one actor behave in multiple ways? Data tables. They're perfect for this. A data table is just a list of variables that's generated by a struct, which in itself is a list of variables. So, all you really need to do is create a struct that contains all the relevant projectile data that you want, then feed that into a data table, and make what are essentially instanced versions of that struct, and then create a projectile that's able to read the data table, and apply the information from that to its projectile movement component so that it can start acting like how the data table says it should act. You need a conventional bullet that just moves normally? Data table it. You need a rocket that starts slow and increases in speed? Data table it. You need a thing that gets affected by gravity? Data table it. You need something that explodes on impact? Data table it. You need something that explodes a while after impact? Data table it. You need something that explodes a certain amount of time in the air? Data table it. Whatever the hell this is supposed to be? Yeah, data table that as well. And what about one projectile that splits into multiple? Take a guess what I'm about to say. And by the way, those split projectiles, they can be data tabled as well. Every example I just showed on the screen was the exact same actor that just read through a different row of the projectile's data table and acted accordingly. Is this simple? Yes and no. It's kind of iffy. But the point is, once this part is done, you have essentially coded every single projectile in the game, and you won't even know what most of them are yet. Step 2, firing the projectiles. This one's a lot more simple to explain. When you want to spawn a projectile, just make sure the component actor moves the inactive projectile to where you want it, and set it to being active. This essentially creates a projectile to fire. This kind of thing may sound complicated at first, even if you've used Unreal for a long time, but it isn't, it's just different. But at the end of the day, it's about as manageable as the old option. It's just, you know, different. When you put it into practice, it doesn't look any different from the spawn actor command, but because of the whole memory fragmenting thing I mentioned earlier and how that's been taken out of the picture, it's way more performance friendly than it would be otherwise. I mean, take a look at just how many actors were spawned in that amount of time. Step 3 would be making the projectile behave how you want. Projectile behavior, I guess. But, realistically, the data table bit from earlier kind of covered that already, so... Step 4, dealing damage. So this can also happen in one of a few hundred different ways, but I'll just explain how I went about doing it. When a projectile hits an object, first it checks if it has the game's damage system in it or not. This system is also a component, and it decides how everything damage-related is handled for each actor it's plugged into. This causes one of two things to happen. First, if it's not an explosive, and the target doesn't have a damage system in it, it just applies a physics impulse that correlates with the direction and flight path and all that, and then just goes inactive. If it does have that health system, it just applies the damage and immediately goes to inactive to fake its despawn. If it is an explosive, then the damage system checks are a little different. First, if the target can be damaged, it immediately explodes, and not only does it deal its full damage, but it also does an extra multiplying factor on top of that for a direct hit. If it doesn't hit something that can take damage, it just waits however long it needs to, and then it detonates. When an explosion is triggered and you're in it, the damage is calculated in one of two ways. First off, if you're in the smaller explosion center hitbox, then you take the full damage. But if you're in the larger explosion hitbox radial thing, you only take a percentage of that damage. And that percentage is decided by how close you are to the edge and how close you are to the center. So, if you're about halfway between the edge and the center, then you'll take 50% of that damage. If you're right on the edge, you'll only take like 1, and if you're really close to the center, you'll take something like 90, for example. It's a distance to percentage kind of thing. One other thing to keep in mind also is that if you take the direct hit with the multiplier, you won't take damage from the big hitbox radius thing. You'll only take the direct hit damage. Now that the damage is dealt, it moves on to step 5, despawning. The projectile disables its trail particle effect, and then it turns invisible, it disables its collisions, and that's it. It doesn't actually move anywhere, it just stays there and doesn't interact with anything. So this is where the most important part of this whole memory fragment aversion comes in, because now this projectile can actually be reused. Instead of it just despawning and a new one is made, it just stays there and waits until it's needed again, and then when it is, it acts exactly like it did just now with that entire spawn, fly, damage cycle. And that's it. There is also the secret step of replication. And this is where things get really, really finicky, but for the sake of it, I think I can explain this. So replication, as far as this is concerned, happens in 2 very specific spots, and it happens in 1 extra spot constantly. 2 spots are spawning the projectile, in a way that doesn't result in it appearing twice or not appearing at all depending on what computer you're on, and then spawning the effects of the projectile. This is also very important because it needs to show up on everyone's screen, because if you don't see the effects, you probably won't see the projectile itself. And then the third one is the replicated movement. While the other ones are just cast to server, multicast back, this one's a little different. What this one does, during the event tick for the server projectile, it'll set its location, the direction it's facing, and how fast it's moving at this very given time, and it'll send that to the projectile that's on everyone's computers. So every tick, the projectile on the player end syncs up to the one on the server end. And that's it. That's all that really needs to be done for replication in this case. It's only a single actor that does one thing and then it leaves, so it doesn't need to do anything too necessarily complex.